Hello, and welcome to the Trepa Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 3.9 PKI, or Public Key Infrastructure. Now let's get started. So, deploying a public key infrastructure in your enterprise is a significant endeavor involving many moving parts. The public key infrastructure is a hierarchical structure that provides authentication, integrity, and confidentiality of your enterprise's users, clients, and servers. We're going to start our PKI journey or our learning journey at the certificate authority. A certificate authority deployed in your enterprise is an application server that will create certificates and is in charge of verifying the authenticity of certificates in your enterprise. Regarding the World Wide Web, a certificate authority is a trusted entity that issues digital certificates with authenticating content sent from web servers. In the PKI hierarchy, there are levels to a certificate authority. The root CA is the most trusted and is the root of what we call the certificate chain. A root CA will authenticate the request sent from the intermediate CA. The intermediate CA is the middleman for the certificate resigning request and the CA. The CSR certificate resigning request coming from, let's say, a user or a server. That's the CSR, certificate signing request. Write this out for you, and we'll go over this later on in this section. The chain of trust is a term that describes how a certificate between the root and an end entity can be trusted. The chain of trust starts with the root, then the intermediate CA, and then the end entity and the user. A registration authority is an agent verifying that a user's request is valid by checking the domain name, identity, and other attributes. Once the RA, or registration authority, decides the request is valid, it will tell the CA to issue a certificate. For example, my site, Trepa Technologies, had to be verified before being assigned a certificate. Once my website was assigned a certificate, it was trusted by a root CA, and anyone connecting to it via HTTPS would not get a certificate error. And then here we have a complete Pki design that shows the flow of the public key infrastructure. You can see the root CA sites on the top, right? Our root CA, and let me get rid of that text for you. So we see our root CA right here. And then we have our intermediate, our issuing certificate authority, right? And then we have our certificate signing requests, which are coming from our end entities down here. Either that web server, this guy's smart card, or some code signing requests, right? And then we have these other servers, which verify whether or not a certificate is valid, or will host they won't verify, but they'll have a list of invalid certificates from the root CA. A wildcard certificate allows an organization to host multiple websites using a single key pair. For example, if I wanted to create a t-shirt shop for Trepa Technologies, but I did not want users to be directed to my original domain of trepatech.com, I could use a wildcard certificate that allows me to have a subdomain like t-shirt.trepatech.com. You see this a lot when you use a CDN for caching. You get issued a wildcard certificate that allows your website to be like cdn.yourwebsite.com. And this stands for Content Delivery Network. In case you didn't know what a CDN was. An extended validation certificate carries a high level of assurance for customers. When an organization uses an extended validation certificate, there will be indicators in the URL bar of the website, like the company logo or a green background, indicating that the company is secure. This is just, again, getting a certificate from a root CA with extra attributes essentially to give it more authenticity, right? A subject alternative name certificate functions similar to a wildcard certificate. Instead of building on an original domain name, though, a subject alternative name will be a multi-domain certificate that can be used for different domains, subdomains, and host names. So you're pretty much using one certificate, SAN certificate, right, for different host names that maybe are all under you, right? So this person has a lot of truck forums. All right. So now let's go over some client and server authentication. So clients can use the public key infrastructure to get issued a certificate and then use that certificate to authenticate on the network. A X.509 certificate is the format clients will use, and this certificate will have that user's information. Certificates issued by CA can be used to sign into a system instead of using a typical username and password. So here we see here our LDAP server, probably running Active Directory users and computers, commonly called ADUC, is integrated into our public key infrastructure. And now instead of a username and password being used to authenticate, we're able to use an X.509 certificate issued to our user. And this probably comes in form of a smart card that gets plugged in. And then we also use a PIN to give us a second factor. A web server or server will also be issued a certificate that a certificate authority will have to trust. So same kind of concept, right? But when a server certificate expires or is compromised, you will actually get an error saying that that website is not trusted. So the difference between a server and a client is that the client gets that certificate to log into that server. The server has a certificate to be authenticated to the CA and to be trusted in the public key infrastructure. So if a certificate is expired or not trusted, they'll still be able to use HTTPS, but it won't be a trusted connection, right? A digital signature is a certificate that provides non-repudiation to a file or data in transit. A digital signature will also be issued from a certificate authority and verifies the authenticity of the user or the data sender. Digital signatures can also be used to sign PDFs or documents online. This is not to be confused with something digitally signed by a mouse or using a service like DocuSign. Digital signatures are token-based and contain certificates issued by a CA. A trusted provider is an organization or entity that hosts a trusted root CA and can provide root certificates to organizations to be linked to the global chain of trust. Now, you can Google all the trusted providers available in the US by just typing in trusted CA providers, right? And then a cross certification is when two or more CAs need to trust each other. They accomplish this by using their secret or private keys to sign a certificate containing their public key of each other. This will enable both chains to trust each other. A CSR, or a certificate signing request, is a message sent from a client or applicant to the public key infrastructure registration authority. This is how an end client or end device applies for a digital identity or a certificate. Lifecycle management is one of the responsibilities of the administrators who run the PKI in your enterprise. Remember, when I said that deploying a PKI is a significant endeavor, the lifecycle management of your public key infrastructure is a task that must be performed often. Certificates will at most only be valid for 13 months before they expire. Some certificates may only last a couple of months, and that's something you have to keep up with, that management of it. Luckily, there are automation tools that can help smooth the process now of the PKI lifecycle management. Certificate pinning protects users from man-in-the-middle attacks by embedding the server's public key into the company website or client software. And if the certificate does match when data is sent, then the client will terminate the connection. Private keys are secret and can never be exposed. They decrypt messages when a user's public key is used to encrypt data. Private keys are also used to sign a message to verify that the message is authentic. Public keys are also used to encrypt data between senders. For example, if Bob wants to send a message to Steve using asymmetric encryption, Bob would encrypt the data using Steve's public key. Bob can do this because the public key is available to the organization. And then once Steve, the receiver, receives the encrypted data, he will decrypt it with his private key. The online certificate status protocol is used for obtaining the revocation status of a certificate. OCSP is less resource intensive and quicker than using a certificate revocation list to check the validity of certificates. OCSP can also be cached to service certificate revocation list requests when the CRL is not available. The CRL stands for Certificate Revocation List. And this is a server or service that will have a list of all the bad or expired certs. OCSP does the same thing, but it's less resource intensive than a CRL. With a certificate revocation list, we could even download one online, and you'll see it'll be like 28 megabits worth of data, right? And if you're trying to query that and download it, right, as a client or a server, that's going to take time and resources. So the OCSP is a quicker way to get the same function as a CRL. Certificate stapling allows the client to trust the server certificate without contacting the CA for a certificate revocation list. Certificate stapling also increases the speed at which a client can verify the validity of certificates. So when a server needs to form a trust relationship, they're going to check the CRL first to make sure that the certificate is valid. Well, certificate stapling, that allows you to trust the server without referencing the CRL from certificate authority. In the last slide, we're going to go over the X.509 certificate and its attributes. So the X.509 certificate is a standard that defines the format for PKI certificates. In an X.509 certificate, the following attributes are listed here on our slide. And the important ones to note here, as far as a test is concerned as well, is the CN, the common name, which is going to be the .com, right? And then here we have the subject alternate names, all the other domains a part of it. And this is also important, the validity period, to make sure that it's still good, right? Everything is important on here, but just some things for the exam, right, to take note of. All right. That is all we have for domain 3.9, which covers the public key infrastructure. Now, I know a lot of you out there that have been studying other videos. People will spend a lot of time on PKI, and they should, because it's very important. For the Security Plus exam, at least it's under my personal belief that a lot of these concepts you just brush up on to be able to pass the exam, right? If you want to learn more about PKI, go to the description below in the YouTube video, or if you're on my website following along, and I'll put some references and other videos for you to watch that really deep dive into PKI and explain it very well from other trainers out there in the world. But that's all we're going to do for our course, because we're just trying to get you to get to that exam, know the concepts and the fundamentals to get you to pass, right? So I want to thank you for viewing this video, and stay tuned for our next video, which will go into domain 4 and cover domain 4.1, assessing organization security. Thank you for viewing.